Okay, this clip will then show you how to calculate the number of grid points needed to do a DNS. Let's take an example of, say we've got a flat plate, 1 meter by 1 meter. We've got a flow coming over it, and there's a boundary layer growing. And let's say by the end of the 1 meter long flat plate, let's just say that the boundary layer thickness is 2 centimeters or 0.02 of a meter high. Let's just take that as our domain and say we're going to do a DNS simulation on that. Let's say the Reynolds number is 10,000 according to this length scale, the flow speed, to give us this 2 centimeter thick boundary layer. That results in a Kolmogorov scale, which we calculated on another clip, equal to 2 times 10 to the minus 5 meters. So this is the scale that we need to resolve. So in order to work out the number of grid points to resolve that scale on this flow domain, we take each dimension in turn. So we've got, for the x direction, we've got 1 meter. And we've got to see how many Kolmogorov scales fit in that 1 meter, so we just divide by 2 times 10 to the minus 5 of a meter. And then in order to resolve the Kolmogorov scale, in the previous clip we said we need four data points in order to resolve it, so this will be 1 Kolmogorov scale resolved. The next one, you'll just need another 3 data points to resolve the next scale, because one of the points is shared. So let's just simplify it and just say we need to multiply this by 3 in order to calculate the number of grid points along this one axis to use in our DNS. And then we've also got to add on the other axis, or multiply on the other axis. So the Kolmogorov scale is 1 meter divided by, again, the same scale, 2 times 10 to the minus 5, and then again we multiply that by 3, and then the final scale in the z direction then is, the height is 0.2, and then we use the same Kolmogorov scale, 2 times 10 to the minus 5, and again multiply that by 3 for the number of points in order to resolve the scale. And all that lot should come out to equal 3.38 times 10 to the 15. So this is the size of the grid, or the number of grid points in order to do a DNS on this particular flat plate example, in order to fully capture all the physics. Okay.